From the vast server farms powering the internet to the smartphones in our pockets, classical computers have been the backbone of our digital revolution. They've transformed how we live, work, and communicate. But as we push the boundaries of what's possible, the limits of classical computing are becoming apparent. In our relentless pursuit of more power and speed, we're now on the brink of a new era. Enter the world of quantum computing. But what makes a quantum computer different from the PCs or supercomputers we use today? It's not just about being faster or more powerful. It's about redefining the very fabric of computation. Where classical computers speak in a language of zeros and ones, quantum computers use qubits, which can exist in multiple states simultaneously. This gives them the potential to solve certain problems that are currently beyond our reach. A classical computer bit must be a 0 or a 1. A quantum bit or qubit, however, can be both 0 and 1 at the same time, thanks to superposition. It's this unique trait, along with entanglement, where qubits that have interacted with each other remain intertwined, that gives quantum computers their incredible processing power. To better understand superposition, we must go back to 1930s. Physicist Erwin Schrödinger proposed a thought experiment. Imagine placing a cat inside a sealed box with a radioactive atom. If the atom decays, it releases poison and the cat dies. If not, the cat lives. But here's the quantum twist. Until we open the box and observe, the cat is considered to be both alive and dead simultaneously. This puzzling concept. It's called superposition. After the phenomenon of superposition, quantum mechanics introduces us to another perplexing behavior, entanglement. In this bizarre dance of fate, qubits forge a bond so strong that the state of one can instantaneously affect its counterpart, even if they're galaxies apart. This isn't mere science fiction, it's a fundamental aspect of our quantum universe. Because of superposition and entanglement, quantum computers can process vast amounts of data and run computations in parallel, making them potentially far more powerful than classical computers for specific tasks. But it's not all smooth sailing. Quantum systems need to be extremely cold, and they're susceptible to external disruptions. Error correction in quantum systems is still a major challenge. Yet the potential is immense. From revolutionizing drug discovery to optimizing logistics and cracking current encryption methods, the applications are vast. Big players like IBM, Google, and many universities are racing to unlock the full potential of quantum computing. The race isn't just for technological dominance, but for reshaping the future. As these giants pour resources and expertise into quantum research, breakthroughs are imminent. The question isn't if, but when and who will make the next big leap. Behind the marvel of quantum computing lies decades of rigorous mathematics and intricate theories. It's a symphony of logic, innovation, and sheer determination. It's a testament to human ingenuity, showing that when faced with seemingly insurmountable challenges, we rise, innovate, and create wonders. As we stand on the brink of this revolutionary shift, every domain, from medicine to finance, will be transformed. Embracing the quantum age, we venture into an exciting epoch of human innovation. Like, share, and subscribe to join us on this journey to witness the marvels of tomorrow.